loss of electron takes place in the case of iron and gain of electron takes place in the case of chromium. In the step 5, add electron in respective side of the half reactions to balance the charges. Electrode potential is generally measured under standard conditions of temperature 298 Kelvin for 1 molar concentration of ions. Hello students, I am Ramya, lecturer in chemistry from Vidhyaashram. Today we are going to discuss about redox reaction session 2. In the previous session we discussed about oxidation, reduction, redox reaction in terms of electron transfer reaction, reducing agent and oxidizing agent, oxidation number or oxidation state. In this particular session we are going to discuss about balance the following redox reaction in the half reaction method, applications of redox reactions, redox reaction and electrode potential process or electrode process and electrode potential. Balance the redox reaction by half-life, half-period method. The given equation, step 1, for given skeleton equation, assign the oxidation number to the atom in the equation and find out of the which atom are undergoing oxidation and reduction reaction. So here Fe2 plus undergo oxidation reaction and chromium undergo reduction reaction. Why? Because plus 2 oxidation state is convert into plus 3 oxidation state and plus 6 oxidation state of chromium is converted into plus 3 oxidation state. Here loss of electron takes place in the case of iron and gain of electron takes place in the case of chromium. In the step 2, separate the equation into half reaction. The oxidation half reaction is Fe2 plus, that is plus 6 to plus 2 to plus 3, and reduction half reaction, that is plus 6 to plus 3 in chromium. Balance the atoms other than oxygen and hydrogen in the half reaction individually. Here the oxidation half reaction is already balanced with respect to the Fe atoms. For the reduction half reaction, we multiplied chromium 3 plus by 2, balance the chromium atom. So here for Cr2O7 2 minus, we have a multiplied with the plus 2 to get the 2 Cr. In the step 4, for the reaction occurring acidic medium and water to be balanced oxygen atom and H plus to be balanced hydrogen atom. Thus, we need to add 14 water molecules and 14 hydrogen ion and 7 water molecule, because we have a oxygen 7. If we want 7 oxygen molecule, we need to add 7 water molecule, then we get 7 oxygen molecule. And for the hydrogen ion, it give rise to 7 into 2, that is 14 hydrogen ion. In the step 5, add electron in respective side of the half reactions to balance the charges. Thus, oxidation and reduction half reactions are written to balance the charge as Fe2 plus addition of 1 electron, and for chromium ion addition of 6 electron, that is chromium 3 plus. It equalizes the number of electron in both the half reaction, multiply the oxidation half reaction by 6, written as 6 Fe2 plus and 6 Fe2 plus plus 6 electron, that is removal of 6 electron. Step 6, add 2 half reaction to get overall reaction and cancel the electrons on each the side. This gives the net ionic equation, that is 6Fe2 plus aqua Cr2O72 minus aqua plus 14H plus give rise to 6Fe3 plus aqua and 2Cr3 plus aqua with the 7 water molecule. This is the final balanced redox equation. Applications of redox reaction. Redox reaction as a basis for titration. In redox system, the titration method can be adapted to determine the strength of the reducing agent and using oxidizing agent, using redox indicators. The use of indicators during the titration can be illustrated as follows. Self-indicator method. During the titration of potassium permanganate with the other oxalic acid or a more salt, that is ferrous ammonium sulfate salt, the permanganate ion acts as self-indicator. After the complete oxidation of reductant oxalate ion or Fe2 plus ion in manganese oxide ion is oxidized itself to manganese 2 plus. During this process, pink color is obtained of, that is manganese oxide is lost at the concentration as low as 10 power minus 2 mole per liter. At this concentration, the reductant and oxidant are equal in terms of their mole stoichiometry. Internal indicator method. During the titration of potassium dichromate with more salt, diphenylamine indicator is added. During this reaction, dichromate ion oxidizes diphenylamine indicator just after the equivalent point to produce intense blue color. This gives end point of the titration. During the oxidation of iodine with Cu2 plus ions, iodine gives intense blue color with a starch. This color disappears as soon as the iodine consumed by the thiosulfate ion. Thus, the end point can easily be detected. Redox reaction and electron process. Working of electrochemical cell. Electrochemical cell is a type of cell which is formed by the electrode, that is a metal rod dipped in its own ion. It gets some potential. Construction of electrochemical cell. Take a 1 molar concentration aqueous zinc sulfate and copper sulfate in a 2 glass beaker. This is 1 molar zinc sulfate solution and this is 1 molar copper sulfate solution which is dipped by its own rod. That means zinc sulfate dipped with zinc rod and copper sulfate dipped with copper rod. These two rods are externally connected through the battery and internally connected through the salt bridge, and that battery is said to be galvanometer. The electrolyte in 2 beakers through a salt bridge. That means the salt bridge is a inverted bent U-shaped tube which is filled by potassium chloride solution or potassium nitrate solution with the cotton plug. Salt bridge used to balance the electrical neutrality. When the reaction takes place, the redox reaction takes place simultaneously, it balances the electrical neutrality in both the solution. So, in the zinc sulfate, oxidation takes place, that is removal of 2 electron takes place. In the copper sulfate, addition of 2 electron takes place, that is reduction takes place. Zinc metal get converted into zinc ion and copper ion which is present in the copper sulfate solution gains 2 electron and convert into copper which is deposited on cathode. Here zinc electrode acts as anode and copper electrode acts as cathode. So this is the construction of electrochemical cell. So it is an example of electrochemical cell. It is said to be Daniell cell. Observation: the beaker placed on left side called oxidation of cell. Here zinc rod get oxidized as zinc 2 plus, and the beaker on right side is called reduction of cell. Here copper ion of copper sulfate reduced to copper. Electrode potential. Electrode potential is defined as the potential difference between the electrode and its ion solution. We call it as electrode potential. So if we consider zinc sulfate solution which is dipped by zinc rod, there is a potential difference between zinc sulfate solution and zinc rod. So this is considered as electrode potential. Electrode potential is generally measured under standard conditions of temperature 298 Kelvin for 1 molar concentration of ions in the solution, and it is called standard electrode potential, and its electrode potential is denoted as E0. Standard electrode potential is denoted as E0. Thank you.